Hello everyone, today we are going to learn about the basic difference between Newton's forward difference and backward difference. In Newton's forward difference, h is equals to xi plus 1 minus xi. H is nothing but the equal interval of x, from which xi plus 1, if we take it as a subject, then xi plus h is equals to, if you substitute in place of I is equals to 0, then x1 is equals to x0 plus h. Similarly, for backward difference, h is equals to xi plus 1 minus xi. That means if you take xi as a subject, xi plus 1 minus h, that means if you substitute I is equals to 0, then x0 is equals to x1 minus h. Similarly, for p is equals to x minus x0 by h. Here we are taking x0 because in Newton's forward difference we are concentrating only on the first terms, but whereas in Newton's backward difference we will concentrate on the nth terms. That means p is equals to x minus xn by h, and the f of x. In place of x, we can substitute x plus h from this minus f of x. So, y1 minus y0 is equals to f of x1 minus f of x0. That means x in place of x1 we can write x0 plus h minus f of x0. So, delta f of x0 is equals to delta y0. So, y2 minus y1. Similarly, f of x2 minus f of x1, in place of x2 we can write x1 plus h minus f of x1. That means f of x1 is nothing but delta y1. So, delta f of x1. So now coming to the Newton's backward difference, del f of x is equals to f of x minus f of x minus h. y1 minus y0 is equals to y is equals to f of x. So in place of y, you can write f of x. y1 f of x1 minus f of x0 is equals to f of x1 minus, instead of x0 you can write x1 minus h. So this is nothing but del f of x1 is equals to del y1. Similarly, y2 minus y1 is equals to f of x2 minus f of x1. f of x2 minus, instead of f of x1 we can write it as x2 minus h. So del f of x2. Del f of x2 is nothing but del y2. Next, this is about Newton divided difference. Here f of x0 comma x1, we are taking the starting terms here because it is a forward difference. So second term minus first term, f of x1 minus f of x0 divided by x1 minus x0. So this can be written as delta f of x1 from Newton's forward difference table divided by h. H is the equal interval between the data points. That means the difference between x0 and x1 is given as h. Next, f of xn comma xn minus 1. Why we took xn comma xn minus 1 here? Because in backward difference we will concentrate on the last terms. N and n minus 1 are the last terms. So second minus first, f of xn minus 1 minus f of xn divided by xn minus 1 minus xn. So if you take minus common from these and cancel out, you will land up with del f of xn divided by h. So the difference between these both is also h. This is the other way of writing the nth term, f of x0, x1, x2, so on up till xn. If you consider Newton forward difference, from starting we have to write. So this can be written as 1 by n factorial h power n delta n f of x0. Why f of x0 is because we are writing it from starting. And now Newton's backward difference, we are starting it from xn. f of xn minus 1, if you write like this, and your last term will become again x0. So we can write this as 1 by n factorial h power n del power n f of x0. Backward difference, this is the last term, so that's why we are writing f of x0. In forward difference, this is the first term, so that's why we are writing f of x0 here. The same thing, but they took it as vice versa in backward difference. Next, f of x is equals to f of x0. So this is the other way of representation of the formulas. So you can see the basic difference between them. F of x naught plus del f of x naught by h into x minus x naught plus del square f of x naught divided by, you have to increase the power by 2 and 2 factorial, and if you have 2 factorial you have to divide the terms by 2. That means x minus x naught and x minus x1 plus so on. And nth term del power n f of x naught h square, instead of 2 factorial, since this is n factorial, nth term, so n factorial, x minus x naught, x minus x1, so on up till x minus xn minus 1. Similarly, f of x is equals to f of xn. Since this is the last term, here this is the first term, so we took it as x naught. Here it is the last term, so that's why we are taking it as n plus del f of xn divided by h, x minus xn plus del square f of xn. 2 factorial, 2 terms, and the degree is also 2, and the power of h is also 2. Next, for nth term, del power n f of xn h degree plus ph. What is the value of p? P is equals to x minus x naught by h. From here, if you take the value of x, then it will become x naught plus ph. So, this is the basic formula, f of x naught plus p into delta f of x naught plus p into p minus 1 by 2 factorial delta square f of x naught plus so on, p into p minus 1 into p minus 2, so on up till p minus n minus 1 terms divided by n factorial delta power n f of x naught. Here the backward difference formula is given as, from p is equals to x minus xn divided by h. We are taking the value of x from here. If you take the value of x is equals to xn plus ph, and f of xn plus ph is equals to f of xn plus p del f of xn plus p into p plus 1. Here we took it as p into p minus 1 by 2 factorial. Here minus for forward difference, here plus for backward difference, and remaining everything will be same. Here instead of delta we are writing it as del. Next, del square f of xn plus p into p plus 1 into p plus 2, so on up till p plus n minus 1 by n factorial del power n f of xn. So this is the basic difference between Newton forward and backward difference. Please like, share and subscribe my channel. Thanks for watching.